All right, good morning. I hope you enjoyed the party last night. I thought it was one of the best parties MMS ever had. Great DJ, great music, great people, great fun, and a lot to consume as well. So I'm very thankful that you decided to take your time this morning, joining this session on maximizing performance on Windows 7. As for usual, I have a Twitter feed running for this session where you can post questions and comments or whatever you feel like. And I will try to glance at it while I'm doing my other stuff on stage. And I also have today a volunteer on the first bench. Michael Niehaus has accepted to keep an eye on it as well and answer questions as they may go along. So if Michael doesn't finish his posting on the task sequence attachment debugger thing, it could be my fault. He's doing that right now. All right, let's get started. Performance for people are different. Performance is different for a hardcore gamer than your probably average office worker. For a hardcore gamer, it's all about getting that final piece out of the graphics processor to get the frame rate going good in the game or have a higher screen resolution. For an office worker, it's like, I would like to be able to boot my machine in reasonable times. I would be able to log on in reasonable times. And I don't want to have to wait too much when I start an application or do something in my system. And with the built-in tools in Windows, it's difficult to troubleshoot, for example, why does my machine take 5 minutes to boot? Why does it take 4 minutes to log on? But luckily, there are tools that we can download and use that can help us troubleshoot even issues like that. So throughout this session, we're going to go through the tools that are available to you, and I will also show you some real hardware and real-world examples on when things went wrong and how we can troubleshoot and how we can fix them. All right. My name is Johan. I'm a Microsoft MVP in setup and deployment, and I will be your host here for the next 72 minutes or so. When we talk about performance, it's much about expectations, especially for people going from XP to Windows 7, which is sort of the current trend right now. I know that many of you are still on XP, but I also know that many of you are already going to Windows 7 or already done it. And expectations is, do you expect that a 5-6-year-old machine will perform because you put Windows 7 on it? Maybe, maybe not. But are there things that you can do? Sure. If you have a 3-year-old laptop, you can buy a $100 solid-state drive and put in it. And that machine will suddenly outperform even a brand new machine bought today, which is not running a solid-state drive. So for those $100, you can have an existing machine behave much more efficiently and faster when running Windows 7 on it. Then it's also important to realize that in Windows, everything we do, we share. Every app is supposed to be friendly with other apps. Because if you start hammering down on disk, if you start hammering down on memory or CPU, whatever, battery, other apps and processes will affect that. They can feel that too. So application developers, they are supposed to write apps that place the good behaving citizen in the system that you have. Because if you don't, your users will look like this. And they are sad. And we don't want that. Now, in Windows 7 altogether, Microsoft spent a great deal of time doing the plumbing to make sure it's performant. And that work actually, believe it or not, that work started with Windows Vista. Windows Vista was not known for its performance, but that's where the ground foundation was laid to the performance we will see now, or have now in Windows 7, and also that we already can see in the betas of Windows 8. It's performant. And the reasons are plenty, but first of all, in Windows 7, that again based on Windows Vista, everything has been tuned to make the most out of your existing hardware. So for example, if you have a nice graphics adapter, it will be able to offload stuff that the normal CPU otherwise would have to do. We also have features like caching, making sure that when you do file copying, Windows is actually lying to you when you do a file copy. Because you do a file copy, and it finishes on the screen. But still in the background, it's still writing stuff to the disk. So even if it appears to go very quickly, it actually allocates the resources in the background to do things. We have the SMB2 protocol in Windows 7, or 2.1 if you look at the SP1 and R2 things. And on a performance point of view, when copying files over the network, compared with XP, at its worst scenario, you get twice the performance by just changing the OS, assuming that the file server they're using is also running an equal high OS, for example, 2008 server. On a WAN, you get minimum 3.5 times the speed, just because you upgraded the OS. You don't have to do anything with switches, with network cards, with anything. Just get that OS up and running, and you will suddenly realize that, all right, it's much more performant. How many of you have tried folder redirection on XP? I have. How will that affect log-on time or log-off time? A little bit, depending on how much files it needs to sync. In Windows 7, they changed that. So that folder redirection is now happening in the background asynchronously, so the Windows can actually do other stuff in the meantime. So you will, in general, see much better performance when using folder redirections in Windows 7. Then there is a feature in Windows 7 I hope you never use, ever. And that's ReadyBoost. Do you know what ReadyBoost is? That's when you attach a high-speed USB stick or USB drive, and you're supposed to use that as memory. It's only applicable if you have sort of less than 2-3 gigs on the box. And if you do, you should not run Windows 7 on it. So rather put in some more memory than try to compensate with adding a USB stick that is supposed to be in the machine all the time. Buy a new computer, buy more memory, do something. Do not use the ReadyBoost feature. Superfetch, however, is cool. Superfetch is when Windows tries to learn how you work with the machine. It tries to learn the apps that you are starting normally when you log into a machine, and you start Outlook, you start Internet Explorer, you start Word, you do your stuff, you start your music player. After like 5-6 times and 5-6 reboots, Windows knows this, and the 7th time you reboot that machine, it will try to load them in advance, so they are available more quickly to you when you work with the machine. We also have a change in how Windows is loading drivers. In the XP time frame, it basically loaded drivers one by one, waited for the first one to load. In Windows 7, we are loading device drivers parallel at the same time. So that's why we can see much faster boot times in Windows 7 than you typically can do with Windows XP. Also now, the industry themselves have about 4 or 5 years now of writing drivers matching the device driver model we also use in Windows 7, because that started with Windows Vista. And still with Windows Vista, device drivers, if I made a top 10 list of performance issues with Windows Vista, 9 out of those 10 could be related to device drivers. But you probably noticed that even after Vista Service Pack 1, even after Vista Service Pack 2, it actually went a little bit better. Was it that because Microsoft suddenly fixed everything in the OS? Yeah, sure, they tuned a few things, but it was mostly because the industry vendors, the driver vendors, finally got their drivers right. And now even Vista started to perform quite good. And that work we can benefit now from in Windows 7 as well. All right. Seeing this? I have. They're normally not that gentle. There are other words in that meaning as well. But it's your job to fix this. If a user comes to you and say, my machine doesn't boot quickly enough, it takes 4 minutes to do a hibernation on it. It takes, again, 7 minutes to log on. How do we fix this? All right. We have tools. First of all, we have the Windows Inbox tools. You have been using those for years. But I will just glance through them quickly and review a few items on them that can help you narrow down problems for performance-related stuff. Of course, you can write your own tools to gather information, because inside Windows, since, early Windows, 2000, there has been logging mechanisms in Windows that we can utilize. But since the Vista timeframe, it really got off because we have the event tracing for Windows that allow us to gather lots and lots of information on a machine, and then we can review that info using various tools. All right, so let's kick off by reviewing some of the inbox tools that we have available. So I will go to a normal Windows 7 machine, a 64-bit machine. And normally, when you right-click Computer and go Properties, you will have a rating about how the system is behaving compared with others. But since this is a virtual machine, if I try to click System Rating, it will fail, because it doesn't do that on VMs. But if you would do that on a physical machine, it will look something like this. You will get the quick index rating to see how much this machine performs. And as you can see, this is a typical laptop, not so good for gaming, but not too bad either. But this is a working machine for an office. All right. First of all, when you experience troubles in performance, you can kick off the normal task manager. You can review processes and such. You can right-click. You can see their priority. I cannot see affinity in here, which I normally would, but this is a VM. I'm running a single logical CPU on this one. But if I would go to my host, which is a nice laptop with a few CPUs in it, I can right-click a process, and I can go set affinity, and I can allow that process to run on either or all of my various CPUs that I have. Quite useful to get old game going in Windows 7. So if you try to figure out how to get StarCraft 1 going on a Windows 7 box, it can help if you actually just run it on one CPU. It was not built for 8. Good to know. All right, back to the client again. The performance info itself gives you a little bit of info about how much memory is being used and cached, and if it's totally pegging the memory, add more. Windows is quite resourceful in finding ways of using your memory. But if you can see it increasing over time, you might have a memory leak, and you might have to troubleshoot that. So how do we do that? Performance monitor. Perf1, good old Perf1, has been around since a long time. I don't remember if it came in NT 3.1, but I sure used it in 3.51. So it's been around for a while, and it actually has looked about the same since. So this is where you can add things to monitor processor information and things like that, and then you can review them in graphs, you can review them in histograms, you can view them in reports, different ways of reviewing that information. But little known is that this friend here actually takes command lines, quite a few of them. But the most useful one, I think, is running perf-mon/report, because that will evaluate your system for a minute, and then it will give you a report about the current status of that system. And that report is going to be quite detailed, as we're going to see here. But while that one is running, I go back to perfmon. There is a shortcut to the resource monitor. Resource monitor is your best friend to find out how a machine is behaving over time. So if I open this one, one thing at a time. Reliability monitor is the best one to make a machine over time. Resource monitor is the current one. That's what I wanted to show you. Reliability monitor. Since this machine was deployed until now, I have every single item that happens on this machine available to me. This is a VM, and I haven't done much with it. But what if I open a screenshot from another machine that has been around for a while, a few good months? You can actually see that, all right, this machine had failures, issues over time. And in this case, for example, on April 4, the machine was not correctly shut down, and the following Ethernet media application and a definition update was installed on the machine. So if you've seen application crashes coming, and if you see a lot of warnings, a lot of red alerts start to come in, you can just drill down to the previous date or a few previous dates to try to figure out, okay, what was going on before this was starting to happen? Because you ask the user and they go, what did you do? And they say nothing. And then you look in here, well, those 45 apps you installed yesterday from that DVD you got from that magazine, do you think that could affect? Yeah, could be. But this could also be that you have an issue. And you can see the application is crashing or doing things 2-3 times a day over a month, and then you get an update from the vendor. This is a very good way to see if that update actually clicked, actually worked, because you have the history over time of the machine. So really useful. The only thing that is not useful with this utility, you cannot run it remotely. But luckily, PowerShell is your friend. And everything this utility can do, you can do in PowerShell. And PowerShell you can sure do remotely. So you can absolutely gather this information if you want to anyway, without having to remote into the machine. Okay. So hopefully my report is now complete. Here we go. I got the diagnostics report with a lot of information. If you click this one up here, you have to know it exists. You will actually get the shortcut to the entire report. So for example, if you want to drill down in desktop rating or BIOS information, you can do that. Plug-and-play IDs, CPUs, network traffic, all that info. What about disk? What about hot files? What are the files that is causing most disk I/O on your machines? And then we can drill down into that and we can review those files. So we have plenty of information here that is being gathered through this minute when this report is running. The resource monitor itself, quite useful for just giving a quick glance. Overview, CPU, memory, disk, networking information, all that you're used to be able to see inside Windows. All right. So what can we do more? Well, we can go outside Windows. We have friends in the industry, now employed by Microsoft. I'm talking about Mr. Rusanovich and sysinternals and former Winternals. All these people, they wrote great tools in the past that saved my life a number of times, and I'm sure a good few of yours as well. They are, of course, still available, and they are still being updated when we want to review what's happening in the system. So the most commonly used tools are actually two tools to find out more information. You have most likely be using either or both of them. The first one is Process Explorer, to allow you to get more details about processes in the system. And this time I had configured Process Explorer to update the speed in, update the view in 5 seconds, or keep the updates in 5 seconds. If you do that change, it's much easier to see when processes comes and goes in this view. Otherwise, they will just click and disappear quickly. So if I start Notepad here, I should be able to see a green line showing that Notepad was started. If I exit Notepad, I should see a red line eventually that Notepad was exited. But because of this 5-second delay, I'll be able to actually spot it. Otherwise, it's easy to miss it. But again, if I start Notepad, I can go properties and I can review detailed information about that process. For example, if you're trying to find out command line strings for an application that is not documented, check strings. It will automatically grab every string it finds in the binary and display it to you. It's also available as a separate utility. Total sidebar, it's useful when you try to find out those hidden command line switches or stuff. But you get the entire environment that this application is using. If it's doing anything on the network, you will see that too. And you will see the performance and other information related to this specific process itself. That also can help you find out which processes are being used the most. In general, this utility is more detailed than your average task manager. And there is an option, so you can actually replace your task manager with this one if you want to when you install it. Another very useful utility is the process monitor. That's normally used for troubleshooting apps, but it can be used as well for performance troubleshooting. Because what Procmon will do, and this is the replacement or successor of the FileMon and RegMon utility that was available before. This utility will monitor everything in the system by default. But luckily, you can set a filter. So if I wanted Process Monitor to monitor only Notepad.exe, I can set a filter to monitor only Notepad.exe. And then when I start Notepad, and if I start a trace, you can now see that it's monitoring everything that Notepad does in my file system and in my registry. And from a performance point of view, you can use this information to see if it's trying to find files, which it doesn't find. So you have to look through multiple locations until it finally finds that file. Or even if it tries to reach out to a network resource that you cannot get at this point. It could be an indication why an application takes so long to boot or to start. But you can also use this to find issues where an application is hammering files on the file system. I had an incident a good few years ago of a customer who was unfortunately running notes. They're now running Exchange or Outlook. And the Domino server, anyway, became to suddenly start to perform very badly. And when we run Process Monitor, we could see that it started to peg down one of these index files really heavily. We saw a lot of reads and writes to that file. And by simply moving that file to a disk volume with more spindles at that time, now we use solid states if you need to get performance, we suddenly got good performance from that application. But without Process Monitor, that would be difficult to see. It would be difficult to find that an application is hammering a specific file multiple times, and by moving it to another system or another spindle, we can get the good performance back again. And that goes for most server applications. You can use this to find out. You can export this output, put it into Excel, just run a sort of a remove all junk, select distinct rows, and you will see the files that are being accessed the most on your system. So that's quite useful. Now, what beyond this? Well, on MSDN, as part of the SDK, there is a utility set called Windows Performance Toolkit. This was being built in the Vista timeframe, but first it was only used by Microsoft internally when they were testing Vista development. But then after a while it was published for free and it's been available now a good few years. It's still going to be available even in Windows 8. If any of you downloaded the new ADK consumer preview that is available, you will actually see that the Performance Toolkit is now included in that kit by default. So again, very useful tools to troubleshoot Windows stuff. So every developer at Microsoft is supposed to know about these tools so that they can troubleshoot and get performance out of their applications. And this utility is reading the information from the event tracing stack in Windows to get that information available to you. Has a bunch of tools in it. I won't cover them all because there are a lot of command line utilities, but these are the 5 most commonly used ones. And of these 5, I would say the top 3 is really useful. Because Xperf is the utility that allows you to start the trace, stop the trace, change the data, export it, sort of control the tracing process. Xperf View is a tool to review the capture, to view the content in it, and start to do analysis. And Xboot Manager is a utility that allows you to start traces during hibernation, during resume, during reboot of the machine. Again, something that's very difficult to do without these tools. The other 2 are more specific to developers. The 4th one is about measuring power consumption for applications, and the other one is to get the information from the program database files that the developer normally use or the debugger use. So, how do these tools look? Well, first of all, I mentioned they are part of the SDK. So if you download the SDK ISO, or you run the SDK web installer, you will get a setup folder. You will have a WinSDK folder with each of the Performance Toolkit stuff. And you can then download it and install it directly. Once installed on the system, if you want to transfer those tools to another machine, you can just copy the folder. There are no services, no registry entries required. You can just simply copy that folder, and you're good to go. So if I open this folder here, this is a folder you copy. If you want to just capture a trace of a system, you don't need all these tools. The only tool you actually need is the perf control DLL and the xperf utility. These 2 files are the only one you need to copy to a system to be able to capture a trace. So if you have a user, the machine is performing badly, something is broken, copy these tools to the machines, run them, get the output, and then you can analyze that on your machine. So the other files are only required to do the analysis of stuff. All right. Let's kick off a trace here. So first of all, Xperf again, starting and stopping traces. But you can define what you want to monitor. So for example, by adding the switch profiles, you can get a listing of available ready-made profiles you can use for capture. And you'll see a bunch of them. And the names look quite weird, but it's not that difficult, because in the right-hand corner, you get a pretty good explanation about what they mean. So for example, the first 2 are for doing I/O traces on file system. The second, number 3 and 4, is to do common performance tests on a system. 5 and 6 are specific for IE8, for example. And for each of them, we normally have 2. So for example, this one is very much like this one. Two versions of the same trace. What's the difference? The difference is, where does it store the data? The first one will store the capture in a file. And that makes sense when you try to review a memory issue or capture a memory issue. The other one that says in buffer, it means store it in memory, which makes perfectly sense if you try to monitor a system or you try to find out file performance, for example. There's no good in doing file performance if you try to store the trace on the file system as well. You really want to store it in memory. And for most of the tests, we will, or you will, use the in-buffer thing. So I will simply copy this one. So I have it available. I don't have to type it. Now, if you want to go detailed, you can actually show every single provider that you can use and monitor. And what you will find is that most components in Windows you can trace, because they are available for tracing to get information about what's going on. But let me kick off a trace using that profile I was showing you. So I will do an xperf. I will start, and I will type in the profile I wanted to use for this trace, for this capture. And it's now starting the trace. Now if I do things, if I open up Internet Explorer, navigate to a website, I kick off MS Paint, I've been using that a lot this week, and do stuff with it. Or if I play a video about how moving to Seattle is like, I can do this. See if we get audio. The audio starts a bit in.
So, you know, there's lots of great reasons to come visit Seattle.
That's right. I came here because of the coffee.
Yeah, everyone knows the coffee.
Yeah. And heard about the drivers?
You know, but then it rains, and it's bad. Yeah, it's bad. But the traffic in general is
Terrible.
okay. Yeah, but you know, the weather.
It doesn't rain all the time.
Yes, it does.
Yeah.
Never mind.
So I'm doing a few things in Windows, and then when I'm done, I will stop the trace by typing stop, and I will specify a folder where I want this trace to be. So I will specify folder and a name, and now it will store that information in that file shortly. All right. And it gives you a good warning. The information you captured may contain personally identifiable information. Yes, it's storing a lot of info from what you were doing in the system. So if you were doing things you were not supposed to at work, yeah, a trace might reveal that. So, right. If I look in that folder now, I have a trace, and you can see it's about 60 megs in size, the one I captured. And the format is not a text file, but we can export it to a text file if we want to. We can export this into a comma-separated text file. So I can, again, run xperf. I can say input, the file in question, and I can say output, and a CSV file in the end. And it will start to convert this now into a text file, which you can drive into Excel or whatever you would like to use to view information in it. And this is where you will find out that the ETL format is a very good format for storing trace information. It's highly compressed, because we will shortly see that the output, when we convert it into text, is bigger. You can see it's about 400, almost 500 megs in size. Do not open that text file in Notepad. It will hang for a long time, if you want to review at least some of it, use type and find the file in question and use more so you can quickly drill through that file. But you can see it's a comma separated file with all the information. But I rather view this file in the xperf view. So I will run xperf. I don't have to specify xperf view because if I specify a file, it will automatically open that file in xperf view. It warns me about being elevated. Do you want it run it unelevated? Yes. And now I see the trace of that capture in the xperf view, the analyzer tool. So this is where I see all information about the CPU. For example, if I want to, I can select the section, I can zoom into it, I can unzoom again, I can clone this, zoom to other items that I have. I can see all my current processes. I can select a filter just to see one or a few of them. I can overlay. For example, here I have the disk IOs or the IO counts. I can go back to my CPU and I can say overlay, and I can overlay with disk IO. So I can also see at the same time, all right, when the CPU spiked, was it because my disk was reading heavily? So I can start to do comparison and see different things. This you cannot do with perf mode in Windows. But you can also drill down into additional details about all the processes. Here, for example, I will see a timeline of all the processes that were happening during this trace. And you can see I was apparently using IE for a while, and then I was using MS Paint for a while. And eventually, I was using the VM Player for a while to catch a movie. But this is where you can see how many processes were running and when they were running. And they can also be used to find out, all right, is it because that process was running at the same time as all the others? Fine. Then it could be why it's not performing very well. So let me go back to the disk here. This is the disk reading. And I can right-click here. I can say, give me a detailed graph of the drive. So this is a 120-some gig drive. So this is all the sectors in the drive. And every time a read and write happen, you can see there is an indicator. If you manage to click it. This apparently was a write on this sector of the disk up here. And luckily, in my case, I have most of my read-writes at the same location of the disk, which is good. Doesn't matter so much if you have solid-state drives, but if you have physical normal drives that rotates, if you start to see applications reading and writing all over the disk, that's bad. Because that means the disk have to stop what it's doing and jump to a different location, and that takes time, rather than reading sequential sectors on the drive. So this will give you a quick overview about how the disk is being utilized and by which processes, and only during this trace. I can also get some information. For example, is write caching enabled? Yes, it was. Good. If it's disabled, you might need to enable it, because that can cause performance issues. Okay. You can also get some information about the system itself. Pretty good summary. It's like MS Info on steroids, almost. But you have the information about the trace, about the disks being used in the system, display information, networking, services running at this time, IRQ being used, and every single device ID on the machine. Can also help you find out information about the computer. On the left-hand corner, you have even more things that you can enable and view. And as you can see, I've only selected a few of them, but you can do additional selections to see more information from that trace that you did. So how does this actually work? Well, this is the event tracing mechanism in Windows. And I will try to make it readable for you, understandable for you. First of all, the event tracing Windows stuff, the big bucket in the bottom of the screen, is the component, the buffers that make tracing possible. And then I showed you, when I did my listing, I showed you the available providers that can be feeding information to that trace. Then we have the XPerf tool that we use to stop and start to control the traces. And when we stop a trace, we don't get the result directly. You might notice when I run the stop, it was actually a pause for a while, and then the summary screen or summary text was displayed. This is when Windows take that dump, which normally would only be available to view on the same machine, and make it able to open that on any other machine. It will also inject other information into the file about your networking, current status and such of the machine. So it adds information to it. And then the resulting ETL file that you get, that one you can simply view in either XPerf, as I showed you recently, or you can export it into text files and do whatever you like with it to find additional information. So this is the flow when we're using the tracing tools in Windows. This is not meant for long-term analysis. This is break-fix things. You have an issue, you run the tool during that time frame, and you review the output. It's very capable of finding lots and lots of data about the system. On an average laptop, it will be able to gather at least 10,000 events per second. So you get very detailed views in the system. If you want to learn more, dive into hardcore, there is a whole section on MSDN related to event tracing alone. Quite nice reading. All right. How about an example? You have a user complaining about the machine is taking too long time to boot. Surprisingly often, it's related to family or a close friend that have installed every software known to man on that machine. But we can use these tools to troubleshoot that. So let me go back to my demo machine. And let me use another tool. Just going to close down a few apps. The X-Boot Manager. So I run X-Boot Manager. I enable trace, and I say boot. I can also do suspend, hibernate, and all those other items. So you can see it's starting trace, and it will now reboot my machine. So make sure you run it on the right machine. So it now rebooted my VM. And since I was using a remote desktop, it's sort of disconnected. But if I go back here, you can see it's rebooting. It's now starting up Windows again. And as soon as it's running, I will be able to log in again. So I will log in. I think it's actually quicker to do this one. And you will see it continues to trace. It has been tracing all the time since I rebooted the machine, all the way when it was started, and it also continues now to monitor that trace for 2 more minutes. And you can specify this if you want to monitor longer. Why? Well, just because you were able to log in doesn't really mean Windows is done. It's still loading processes in the background at this time. And if you're troubleshooting login processes, they are great to find that information. Now I don't have too much software in this one, so I will simply click Finish, and it will stop the trace, add the information I talked about before, again give you a good warning about identifiable information, and then I will be able to review that info again. So I will try to remote into it so I can use the correct screen resolution. VM Connect is not really capable of doing 1280 by 720. And the irony is that every projector on a Microsoft conference is using that resolution. So I have to use remote desktop because remote desktop can. See if I get in. It's coming. Perfect opportunity to monitor the feed. The question is, how do I troubleshoot group policy? That's a good question. It's one of them. Yep, I just showed you. This will actually show you also the group policy processing taking place. So I'm back to my machine. Let me go back to the folder I was in. This is where you see the output. This is my trace from a boot. And you can see it's about 18 megs in size. So I can open that trace in Xperf or Xperf view. Hello, my friend. And I need to type correctly as well. So I'm opening the trace, and now I see the same information, but this time all the way through the boot that I have. And for example, I can see all the disk IOs being done on the machine, and not surprisingly, most of them were in the beginning, where it's loading the kernel and all those stuff. But here I will also see all the processes that happened during this time frame. So I will see how much time Windows actually spent doing on things related to, in this case, processes. But I can even do more details about this. This is where I can see, and let me start Summit again because it sort of died when I rebooted. This is where I can see all the individual components, and you can see Windows Defender started here, the policy agent was started here, and all the different processes that happen. But this was a VM. What about the trace from a real machine in production? All right, I happen to have one. So let me see where I put that one. Do trace, yeah, that's the one. A bit larger trace, because that machine had a lot of applications, a lot of processes. You can see the information, it's a bit more detailed here, but again, you can drill down, you can zoom in, you can do all that stuff. So if I go down here now, I will be able to see information that you would normally see. All right. Google Crash Handler was loading at this time. Not surprisingly, Flash update service were running at this time. And this is the Storegate. It's the online backup I'm using for my machine. But this allows to see what's going on in the system. And even, again, in more details, I will see a bunch of information about what's going on in my system. Apparently, iTunes was installed. Windows Search was kicking on. The Steam client for Skyrim. Great game, I love it. It's starting in. And then you can see all the other stuff that is starting later. You can see it's running a group policy update. You can see HP Health Check service kicking in, Windows Update kicking in. Again, a bunch of updates kicking in. And without this tracing information, this is a nightmare to find out stuff like this. But now, for example, if I would see that, now it didn't, but what if the HP stuff was taking a really long time to load? Well, uninstall it and see if it helps. So, very useful info. So by using the Xboot trace and the boot manager trace, we can very easily navigate and quickly find this. You can please run it together and review the disk I/O at the same time. Because again, disk I/O is the single most common reason for performance issues in Windows 7. What if device is not performing? This was a case when a mouse driver vendor, who we will not name, but they're known for intelligent mices, had a driver version that was not very good. Do they have trains in this building that I don't know about? Anyway, this device driver, when I was using the mice, it will stutter. It will stutter all the time on the machine. And that could be related to an application performing badly, but it can also be that driver. But again, how do we find it? Well, start a trace and get that going. So again, I will use xperf, and I will find that trace. In a week. Put it here somewhere. There. So this is a trace being captured. And again, if you look at the trace directly, there is not much information that this system was performing that badly, because the CPU was quite low and the disk wasn't using much either, and well, not too much stuff was going on. I mean, CPU usage of 1%, that's right fine. But when you enable deferred procedure calls, this one, you will see information about hardware, what they are doing to the system. Because every hardware needs to have access to the CPU in one way or another through interrupts. And if you have a hardware device that is starting to peg that CPU with requests, that can cause overall performance of the entire machine. And in this case, so much that the mouse actually would stutter. So if I enable this one and drill down to that section, which is right here, you can see that from a deferred procedure call perspective, it was hammering the CPU. So let us select a few seconds of time here and drive in and do the summary of this. So I right-click and do summary. And now I can see in that selected time frame, I actually had a driver that was, in comparison with all other stuff going on that system, using a lot of resources, a lot of calls to the CPU. The fix, update the driver, the vendor had one new available, and life was good again. But again, without these tools, not very easy to find this information at all. Any questions? Anything that left you in awe and wonder? Have you seen these tools before? How many have used these tools before? That's about 20% of the people in the room. So I guess for the other ones, these tools are probably new to you. But they can prove to be a very powerful ally. And in the future, it's being great because, as I said, it's being added to the ADK, and they're also adding in stuff, services, consoles to allow you to do this remotely without having to do it on the machine itself. It's quite nice. All right, summary for that one. Use the trace to find information about hardware, and you'll be able to nail down performance issues like that. So with that, I will say over and out for MMS for this time. It's been 5 great sessions and 5 great days. I had a lot of fun. So enjoy the final 2 or final sessions here. And thank you all for attending and making this week great.